Hey guys, in the comments on my video about selenic acid, one viewer asked me to create a Piranha solution by substituting sulfuric acid with selenic acid. I took anhydrous selenic acid, which instantly crystallizes upon contact with selenic acid crystals. In fact, I thought about this for a long time, and after I synthesized anhydrous selenic acid, I finally had the opportunity to compare the usual Piranha solution that you all know with a selenic acid Piranha solution. By the way, you can learn more about the properties of selenic acid from my video about this substance. Then I began adding cold 60% hydrogen peroxide to selenic acid. 60% is the maximum concentration of a commercially available reagent. I perform all reactions in a small volume, because selenic acid is 100 times more expensive than sulfuric acid, and I cannot afford to dissolve massive objects, for example a whole sausage in this Piranha solution. So we'll limit ourselves to a small piece of sausage. Similar to a regular Piranha solution, it dissolves quickly when heated. A match also easily and quickly dissolves in the upgraded Piranha solution, leaving behind a precipitate of red selenium formed during the reaction. A piece of paper also dissolved very quickly. Finally, I took my tooth, which the tooth fairy had given up, to put it to good use. After my tooth came into contact with the Piranha solution, it first darkened and then became white. The color of the solution changed from transparent to light brown, becoming more and more transparent as the tooth dissolved. In summary, both Piranhas were great, but the dissolution of substances in the sulfuric acid Piranha looks more effective. In most reactions, a clean transparent liquid remains, unlike the selenic acid Piranha solution, where we very often get a dark red cloudy liquid due to red selenium precipitating. When the tooth completely dissolved, the solution turned into a cloudy, colorless slurry. I don't think there is anything that only sulfuric acid Piranha can dissolve. However, gold is something that only selenic Piranha can dissolve. On the left, we have a typical Piranha solution. On the right, a selenic Piranha. I added a little gold foil to both mixtures. When heated, selenic Piranha quickly dissolves gold, unlike sulfuric, where no matter how much I heat it, gold doesn't dissolve. In fact, while preparing this video, I wanted to create an even more potent mixture using selenium trioxide. I tried to obtain it in the same way as sulfur trioxide is obtained from sulfuric acid, by adding anhydrous acid to phosphorus pentoxide while heating. After some time, I discovered crystals had formed in the connecting tube, and a small amount of clear liquid had collected in the receiving flask. The latter was strange, because this liquid did not solidify, even though the melting point of selenium trioxide is higher than that of sulfur trioxide. Beautiful snow-white crystals grew inside the reaction flask. I doubted it was selenium trioxide, because, upon opening the flask, I didn't notice any smoke. Selenium trioxide should smoke in the air. Then I decided to add alcohol to it, because, based on the description of the properties of selenium trioxide, it ignites many organic substances, including ethanol. However, the reaction didn't occur with either the crystals of the substance or the liquid in the flask. However, when they were added to selenic acid, no crystallization occurred. Since no violent reaction occurred when water was added to these needle crystals, we can also conclude that these are not sublimated phosphorus pentoxide crystals. If this were selenic acid, it would easily dissolve gold. However, this also didn't happen. Thus, we can conclude that these crystals represent selenium dioxide, which formed during the decomposition of selenic acid due to heating of the mixture. The small amount of liquid in the flask was selenic acid. I know this video was not very spectacular, but it answered the question about selenic piranha, which interested many, including me. Thanks for watching, guys, and a special shout out to my patrons for their support. They help cover part of the cost associated with the production of chemical content. You can also contribute by becoming my patron through the link in the description. Hope you enjoyed, see you in the next video.